domain. It contains both the data pipeline as well as the AI machine learning models. So I have worked for various organizations, starting with Cognizant, then Accenture, and currently in Capgemini for the past 11 plus years. And as Trupti has mentioned, I have worked on the various tools and technologies involving the data modeling, data analysis, data architecture, and so on. So as we all know, we have connected to share my knowledge in the machine learning, which I have gained the past 2.5 years. So the agenda for today's discussion will be, I will be highlighting on the machine learning overview, then what is the key difference between supervised and unsupervised models, and then a few more deep down into the supervised models with example of case studies. I would make it, I would love to be more interactive in this session, and few question and answers and the conclusion, right? So without, before I proceed, right, any one or two responses or answers from you all, what you all know about AI and ML. Can I get some couple of quick answers in the next 1 minute? Feel free to, don't worry about whether it is right or wrong, just whatever you know, feel free to share. Yeah.
It is open to you. You can unmute and respond. Participants, please unmute and respond.
Machine learning is a subset of what deep learning, and deep learning we can say it is a set of machine learning.
Okay.
Actually, AI is a subset of ML is a subset of AI. And
ML is a subset of AI, and deep learning is a subset of ML.
Okay.
I also have the same views. AI have different areas like machine learning, export system, robotics, natural language processing. These are all few areas under artificial intelligence. And your deep learning is a part of machine learning. Deep learning is a part of machine learning.
Okay.
Thank you.
Okay.
Thank you.
And deep learning is used to solve the neural network problems.
Okay. Great. Yeah, I think you're all more or less you're absolutely right. But what I would give more stress on is to understand the fundamentals first, then getting into a bit more details, right? So the primary purpose for why machine learning or AI or deep learning, why it all came into the existence, right? The main objective of all these technologies or concepts came into because we wanted to build a non-human automated systems to understand what are all the various business problems that are there in the real world, and how, as unlike human beings, how the systems or the machines will learn from those business problems, right? When I say business problems, it may be how to solve the traffic problem, how to solve someone is trying to someone is trying to hack our banking products, or trying to hack our banking login ID credentials, or someone has misused our credit card. So there might be n number of business problems, or someone trying to detect what kind of a disease a person is or having it, whether he has cancer or not. So there are various sectors in the real world. Maybe it may be supply chain, or it may be banking or retail or healthcare or satellite, or various control, electrical various telecommunications. So there might be n number of problems where we wanted to reduce the human intervention by building various automated models, right? So, and take the decision smartly to rectify or to prevent those business problems that we need to achieve. So that is the main objective of building this AI or machine learning models. So as some of you have rightly said, the AI is, as you can see in this screen share, the AI is right from understanding the business problems of the real world, building some machine learning or automated mathematical models, and using those models, how are we going to take the decisions and to prevent or to uh, how we can solve those problems is what about the machine learning. So in simple terms, machine learning is nothing but it is precisely summarizing in automated mathematical models by learning from the data. So what is learning from the data? It is all the observations from the real world. Suppose you are going through from a point A to point B using certain traffic route. How are you going to know whether on that particular day whether there will be too much of traffic or less traffic, or the road is blocked, or those things? How you are going to know that? How mathematical model you can build based on that, you can derive it. But what is AI? It is not only from here to here. You also have to take some decisions based on the model that you have built. That is what the complete AI pack is. Now, as this session is primarily so I would be taking both on supervised and unsupervised models. So by today's session, I will cover more on the supervised models in machine learning. And what you mean by supervised is, see, there might be two primarily endpoints, right? So whether you would be knowing what should have been the desired output using the mathematical models, that would be calling as a supervised machine learning model. And if you don't know what would be the desired output, which I will be taking the session more deep down in the next session, that would be the unsupervised models. Okay, so just keep it very simple. Supervised is nothing but building an automated mathematical models by learning from the data, which contains both input and desired output as a target. But if you don't know what would be the desired output, that you will call as a unsupervised model. Okay, till now we have spoke about what is supervised, unsupervised, what is AI, what is machine learning, what is decision making, and all. I would go to speak about the two primary types of machine learning models. Okay, so what are those? Those are, one is called a regression machine learning supervised model. Another one is the classification machine learning supervised model. Okay, so what we call as a regression, because if our output, so based on certain input data, if our output is a continuous number, right? For example, if you have been saving for the past 1 year, you are doing multiple banking transactions. So what you might do in the next coming one month or 1 year, how many transactions you might be doing it, or how much amount of you might be spending, that is a continuous number, right? So based on your past or historical pattern, what would be your, in future, what would be your pattern of pattern of purchasing an amount, that is a continuous amount, that we will call as a regression techniques. What we call is a classification, because, for example, if you have been studying for the past 1 year every day 2 hours or 3 hours, and based on that pattern, suppose there are 80 or 90 students, if they study for the past 1 year every day 2 hours, they are able to score more than 90% of marks. If they score, if they study only 1 hour per day, suppose they are scoring about less than 90% of marks, right? So the grade A or grade B, whether they would be able to get the grade A or grade B based on certain pattern. Okay, that is not something a continuous number that we call as a. If you want to build those kind of a models, we call that as a classification models. Any doubts till now? Because I wanted you to understand these concepts before I go to more detail into the hands-on or the practical examples. Any one or two quick doubts or concerns or queries you have, please let me know.
It's fine. As of now, it's fine.
Okay, very good. Now the next various other concepts that you would be coming across is what would be the, so when you calculate, when you based on certain past pattern, right, whether it is a regression or a classification, you will be primarily you will be getting an output of the predicted output from the past actual data, right? So
excuse me, sir. Excuse me. Can you please hide this which appears? Yes, which appears at the bottom.
Okay.
You can hide it. Click at hide.
Okay, is it fine?
Thank you, sir.
Yeah, no problem. So when you derive the based on past history trends, when you actually predict the output may be a regression output or it may be a classification one, right? So there will be some noise, right? Some, for example, if you calculate the let me give an example. Suppose you are storing for the past 1 year. Suppose you are storing amount 100 rupees per month, and you have been storing it, and based on that particular amount, if you calculate what might be my future amount of storing, you calculate that y predicted value, right? So for the future period. Now, what would be the difference, or what would be the error in the actual values and the predicted values that we need to reduce? Because that is, if we don't reduce that, our models will not be having accurate reflection of what exactly we need to achieve, right? So how we're going to calculate the various errors of measures for different types of machine learning models? There are many various. Like for example, in regression, you have root mean square error or mean absolute error. These are the two primary types. There are various ways of other errors as well, but we need you need to calculate these two errors and then fine tune your machine learning models to minimize these errors as much as you can. Similarly, when it comes to classification, there are basically, I would like to mention here, the classifications would be of two types again. The outputs, for example, it is a pass or fail, or a grade A or grade B or grade C. That might be one type of classification outputs. Or there might be also another type of classification outputs where you will derive the probability of the outcome. How much percentage of how much will be the probability of tomorrow it may rain or it may not rain? How much probability of a flight coming in time or it will be delayed? So those probabilistic output also you can derive or define using the classification models. So when it comes to classification outputs as yes or no type or different labels as an outcome, for those there are various performance measures that are available, that have been built or that has been known for you all to understand and then fine tune or optimize your models that you're going to build on it. So before coming to these nomenclature or these definitions, we generally, what we do is we build a confusion matrix when it comes to the classification. What is the confusion matrix? If your prediction, suppose you have true or false, and if the actual value is suppose true and false, so we have 4 types of parameters that you can come up with. For example, if your actual is true and if your predicted also true, we call that a true positive. Then similarly, true negative. Here it is false positive and false negative. So these 4 values, okay, you should calculate when you do the classification things. And with this, when you do the when you term the confusion matrix as an output, then you will automatically can calculate on the various parameters of performance measures. For example, when accuracy is calculated as you have to sum true positive and true negative by divided by all. So like that, various other measures are there. I would not like to spend more time here, but this is for your awareness or understanding point of view, that all these measures you need to calculate. That will help you to optimize your models. But one thing I would like to keep you all aware that these 2 errors, what you are calling here, right, false positive or false negative, these are very important in terms of machine learning models. So we should ideally, these 2 should be 0, but in general, when you build any model, these 2 will never be 0. So you need to minimize these numbers. You will come across all these things when I show the demo or hands-on example, but keep that in mind that these 2 are also very important, and you should see that wherever you have accuracy, it should be more, or precision or recall, these parameters should be kept in mind when you define it. Similarly, when your output is a probabilistic output, you should think about you should draw a graph, right, with false positive ratio and a true positive ratio. So when you draw a graph using a false FPR and TPR, this false positive ratio is nothing but 1 minus your this one minus your specificity. Basically, true negative ratio, it is opposite of that. So when you draw a curve using these 2 values, then what will be your area under the curve or region under the curve, that you have to ensure you should pick a model which has the largest area under the curve. That is one way of getting the optimized or find best model that in your available resources. Similarly, there might be another way of finding is how you can say the Gini coefficient should be maximus. What is Gini coefficient? Generally, all these terms you just be aware, because in Python, right, there are already built specified libraries where you should use those to find out what is the Gini coefficient or what is the ROC curve or what is accuracy. All those things you can easily get from the libraries that are there in Python. But concept wise, you should also know how Python uses these formulas or these mathematical functions to derive that, so that if you know, you can write your own piece of code to identify or extract the optimized model, right? Any questions till now? Please feel free to ask. I will pause for a minute before I proceed to next slide.
What is the full form of ROC curve? What is the full form of ROC?
Okay, it is region under curve, ROC. Am I did I answer your question?
Yes, sir.
Okay. Mm-hmm.
Excuse me.
Mm-hmm. Yeah.
So could you please explain what is the underfitting and overfitting, and when we will get the underfitting and overfitting in the model?
Very good question. Okay, I will park this question for next 10 minutes. Okay, when I explain about the train and test data, I would explain to it. Okay, I would explain that in some time. But it's a very good question. Yeah. Any more questions till now?
Excuse me, sir.
Mm-hmm.
Sir, what exactly this Gini coefficient signifies? What is its interpretation, Gini coefficient?
Okay.
What we infer out of it?
Okay. Okay. All right.
Yeah.
So let me just see. I have given. Let me just expand this particular piece. Right? Can you all see my screen?
Yes, sir, we can see.
Okay. Okay. So when you draw a graph between FPR and TPR, okay, there will be various data points, right? Your curve will be like this. Okay, your curve is like this. Now you should draw a straight line. When it comes to a linear regression, you should draw a straight line from your point of origin to your final destination, and the area under the curve get less than this, beyond this particular line is called as the area of curve. We call that as the AOC, and the area under beyond this curve um, till your left side of the origin is called the point B. Now, what you both Gini coefficient and the ROC curve both are measures of the performance for your probabilistic output. So you should see that how maximum you should get the Gini coefficient or the ROC curve. Now, if you see it here, as you can see it here, now Gini coefficient is nothing but you are this area which you call A by the total area A plus B. But ideally speaking, what is A plus B? It is half of the entire rectangle which you can see it here, isn't it? This area, whatever you are seeing it here, I would explain whenever with a practical example, but the area that you are seeing it here, A plus B. What is the A plus B? It is half of the area of this particular rectangle. Yes?
Right, sir.
Now, and what is A? A is nothing but your area under curve, which is this area minus 0.5 of the rectangle, this area. You are minus subtracting this area. This triangle, what I can see it here, this is half of your total area, yes or no, of this rectangle?
Yes, sir.
Okay. Now, so what I am trying to define now here is, when I say A by A plus B, I am telling A is I'm replicating by total area under curve minus 0.5, which is this area. Okay, only this the lines where I have drawn here, by A plus B. A plus B is nothing but your 0.5 of A. Now, what Gini index is telling you is, if your twice of your area under the curve, generally if you simplify it, minus 1, if that value is more, that will tell you that your model, what you have built, is the optimized model. You might build the model for various parameters, right? I will show you in the next example. You will build a model using various parameters. There might be various various learning parameters that you will use in your model building. Using those various parameters, what will be your Gini index or what will be your ROC curve area? If you have a maximum of these values, that will tell you whether this model has the best optimizing model or not. If it has a less value, then you need to find ways how to tune that particular model. When I say tuning, it is optimize that model with various other parameters that are there in your model. When you build the models, that will give you exactly what would be your best model. You will come to know about it once I show you one example, but in concept wise, this should be your objective when you want to build a best model. Are we clear till now?
Yes, sir.
Okay. Okay, so I will come to Ansible techniques a little bit later, but because I see the interest in all of you with more practical examples. So before I proceed to show you a real use case example, you need to keep certain things in mind. Okay, what would be the key steps or primary
Excuse
steps?
me, sorry to interrupt you, Vikram.
Mhm.
Can you please make it presentation mode?
Okay, okay, sure. Yeah,
Thank you.
yeah. So when you build any model, right, there might be n number of steps that you should do when you build any model. What are those steps? Basically, the first step is definitely you need to import the various data set that you have, and the various libraries that Python has. Okay, uh, to that you can call in course of your program that you would be building on. So all those libraries or the data sets you should import at the beginning of your code. Once you import, what you need to do is there is a data preparatory, or we call that as a exploratory data analysis that contains, you should analyze whatever data is there. You should plot some of the graphs or some of the analysis. We call it as a univariate analysis or bivariate analysis or multivariate analysis. You should see whether the data that is there is in the right format. There might be some of the data that you have might have null values or redundant values, or if there is no dependency or correlation between two variables. Okay, that you need to give more stress on that. So all those data analysis and also data preparation or a pre-processing phase you should do before you actually start building in your model. Once these three activities are done, then you should start building model. And then once you build a model, you should try to see how you can optimize the model. So from here till here, that is where all your performance measures, that these things are there, right? You should start looking into displaying all these performance measures as applicable, and then you should tune the model with more trial and errors. Then finally you should test and give your desired output, with it may be a regression output or it may be a classification output. So these steps you should be doing in a systematic way, so that for the sake of building a model you should not do it. You should give stress to each and every phase of it and understand the data first and then build the model. That is where it will help you all in building a right model as per your data, right? So one of the question that was prompted or asked was, what is underfitting, what is overfitting, how you can reduce that, right? So let me, before I go to show the examples, let me show the example itself, right? 1 minute. Okay, can you see my screen here?
Yes, sir. Yes, sir.
Okay. Yeah, before I explain that, I would like to speak take few minutes on the interface or the tool or the basically a tool that I would be using to show you all, right? Hope you all have access to Colab, Google Colab. Did you all have access to Google Colab? I hope yes.
No, sir.
Okay. Does anyone know what is Colab? Google Colab, anyone knows? Okay, no worries. So see, anyone having a Gmail account, okay, you all can, there are n number of ways where you can build, you can basically, what you need to do is you need to write a Python code, right? Python is one of the programming languages that predominantly being used for building all the machine learning models, okay. There are other programming languages as well, like R or SAS or Spark mlib library or Databricks. There are various n number of other programming languages also where you can use machine learning. We can use machine to build machine learning models. Okay, Python is one among them. So you can also install Anaconda. There is one Anaconda tool. Okay, you can install that. But for all of you, Google generally, for all the learners primarily, what Google gives is you can log into collab.research.google.com, where the you can just import. You don't need to install any Python or any local programming languages. You can just log into this collab.research.google.com, and then you can build or write your own Python program or machine learning models for your own learning point of view. Okay, so I would say at least few of you, if you have access, why don't you go to this particular URL? Let me ping it on the chat. You go there, and so that you can try right away, right? Where is this? Yeah. Okay, I see there are a few questions also. Sorry, I could not see that. Yeah, so Vaishali was telling it is a platform which provides virtual GPU for programming. Yeah, that is correct. So I primarily use Google Colab to build the various machine learning models. Okay, so you all have the data set that I shared with my friend Trupti. Do you have all the data sets?
Yes, sir.
Okay. Okay. So how you want to make it, right? Let us make it more interactive from now onwards, especially. let us use first, I will show you an example of the linear regression, right? So I showed you at the beginning of the on the page 4, I told you about two types of models, right? One is the linear regression, one is the classification, right? Let us first see a small simple example using the linear regression machine learning model. Okay, one thing I would like to say here is, please understand the concepts, and using these concepts you can implement in any one of your applications, right? You might use that for finding a signal strength if there are few electronics and telecommunication students, or if you wanted to do in mechanical or instrumentation or metallurgy, you can find the bending, how much the bending can be for various strengths or various materials or various features that you are going to imply. All those you can implement the same concepts, okay? But the fundamental principle is, you have a set of data, and based on data you are finding in the linear regression model, you are basically, what you are doing, you are finding a equation, a function, okay, where, for example, let me show you here. Okay, basically what you are doing, in mathematics, what you call y is equal to ax plus b, right? What is a here, what is x here? X is the input parameter. Okay, based on your data set, you are finding the values of a and b, so that what will be your target output, y. So you have a set of input and output. Let me show you here this AutoMG data set. In the AutoMG data set, what you are having it, basically you have, this is y variable, what is miles per gallon. You have all these input variables. Okay, how many cylinders, how much is the displacement, what is the horsepower, what is the weight of that car, how much acceleration it has, what is the which year the model is, based on when it was originated. So for all these, we call this as a features or input independent variables, right? But this is your dependent variable. So this will be your y value, this will be, all these are all various x values, right? Now based on these parameters, we have seen the actual value is all this. Now in future, if we have come across any one of these combination, right, if we come across, what would be the predicted output? That is what we are going to calculate using this model which I'm going to show. So, and suppose the output is 14, then it is near to your actual output, isn't it? So similarly, for various other parameters, you will come across the actual output. So that's why I call it as a regression model, because these are all continuous values. It is not a class or a label. It is not 1 or 0 or yes or no. It is a continuous variable. That's why we call it as a linear call as a regression problem. And why it is a linear regression? The linear regression because it is of the equation is for ax plus b. So you are trying to build an equation in a ax plus b format, so that your output will be in that model. Please remember that this output or this model ax plus b, it may not be always true. Okay, it may be any function. It may be also, as I can see here, e to the power of, I say, ax plus b. Any equation you can have, okay? Any equation of y you can have it. So, but in this example, for any, as you are all beginners, so for any model that you build, linear regression gives you a linear equation, linear output, right? So that's why. Now, any one of you have any luck to log in into the Collab tool, or some of you?
Yes, sir.
Yes, sir, we opened.
We opened, right? Okay. So you are on this particular. So when you opened, what did it come? You might have come a blank page like this, isn't it?
Actually, they are asking to increase the font size in the collab page, so you can zoom it a bit. Yeah.
Here, huh? Okay. Is it fine, or I should make it more? Let me make 20. Is it fine, visible?
Yes, now it is.
Yes, yes. Now it
Okay.
is.
Okay. Okay. Okay, but you all can see the. I hope some of you have already opened the Collab tool, right?
Yes, sir.
Okay. So I will just give you a brief 2 minutes overview on this particular. You should be familiar with this, how we are going to use this particular UI. Okay. So on the Collab, Google Collab, whenever you open it, you will have something like this. Okay. Now here you have various. It's just a file operation, right? If you say locate new notebook or open notebook or upload, for example, if you have already written a Python, okay, and you wanted to upload that, right, which I have done. For example, here what I have done is I have my already written for my as part of learning or for my projects, whatever. In this example, I have done specifically for you all people. So all these examples we have already written it before, right? I can just upload it and show it to you, right? Similarly, if you want to, this is one particular cell. If you want to add another cell to it, you have to just say plus. If you want to give some description of whatever you are doing it, you can say text. It will automatically do add the cell. Similarly, if you wanted to append, right, upload any file, that any data input that you wanted to use, you can click on this particular icon, and then you can go click here and you can take that file from here, right? So then how are you going to run? For example, if I wanted to, for example, in this case, right, I am just copying here my code. Copying my code, and I am running it, right? Run this, run all, just say. So it has been executed, right? Similarly, if you have all set of things, you can run all and do it. Similarly, you can restart the run, or if you want to stop it, you can do interrupt. If you want to manage the session, suppose how many sessions are there? If you terminate this one, right, this one will get disconnected. So it is more self-explanatory, but you should always play around this. Initially, you will need to spend a bit more time to get familiar with this tool, but it is not something very difficult. Okay, being the students of the engineering college, you should be able to learn quickly. Okay, any things you come across, any issues, you can definitely reach out to me in the next session. But this is something you should be aware. Now, what I have done here is, in this particular example, what is the problem that I'm trying to solve, right? So what basically I have been asked, this is a set of data. Based on this data, I am trying to build a linear regression machine learning model where all the features will be my inputs and I will derive a output, the what will be the miles per gallon. That is what the simple ask that I have. To achieve that, what are the things that I need to do? As I explained, you have to follow through various steps, right? One is the importing, then the data import, then library import. Then I will go through the various EDA analysis, right? Exploratory data analysis that I would be doing various. But more important in this model or in this exercise will be to draw these various plots using the Python. Okay, so at the first instance, you might be looking little more um, um, concerned, but trust me, all these things, if you practice at least 3 or 4 times, you will get familiarized yourself, and it will be not very much difficult for all you to pick it up. The primary of the main part, right, of this entire model, definitely I will go through one by one more each piece of the code. The main part of the entire model is to get this particular score, right? The performance measure, what I have said, should be maximum. So when I say 0.81, that means in this example, when the model that I have built, it is 0.8% of my actual miles per gallon. So that is something you need to see how you can improvise more, because as it is a linear regression model, this is the maximum I can get it. But ideally, whenever you build any model, that should be you should try to achieve minimum 90% of the accuracy or the ROC curve. Now, one question what I was asked is on the underfitting and overfitting, right? So whenever you build any model, right? Any model you build, what generally we do, one of the exercises what we do is we segregate this whole set of input data. We have around 3,592 records, right? We segregate this into two categories. Okay, one is training data. Okay, the other one is the test data. Okay, now what is this training and test data? Basically, out of these 3592 records, you will split that into two subsets. One is the training data subset, one is the test data subset. How you will do it? The traditional method is we take as a 70% of the total data to be trained data set, and remaining 30% is your test data set. It is not mandatory, but these are all something that you can trial and error. So you can make it to 90% and 10% also. Okay, it all depends on how you get the maximum maximum performance of that particular model you build it, right? So you can trial and error with these percentages. So what is underfitting is, okay, before that, so when you build any model, right, you build a model. Generally what we do is we build a model using the training data, and then we implement that model using on the test data to find whether whatever models we have built, how much close or how much how much near accuracy that model is with respect to our target output, right? So if you have taken very less data, for example, if I say 40% of data I use in training and 60% of data I used for testing, that will help, that will, what it will result, it will result in you might not cover all the permutations and combinations of this input data, the various combinations you might not have covered, isn't it? You might have skipped some of the combinations in this 40% data. Now, when you do this with less number of data set, then you build a model on top of that. It will definitely not be very much accurate or very much optimized when you implement the same model with a different set of data. I mean, here test data, where there might be new scenarios, right? New combinations of the data that would be there. So in that case, in this particular scenario, what we call it as, we are basically, our model is underfit model. Okay, our model has not covered all the various permutations or combination of the data, input data. Similarly, if you make this one as a 95%, and if you make this as a 5%, right? In this case, I'm just telling, this is just an example, okay? But I'm just trying to explain what is underfitting, what is overfitting. Now, in this particular example, in this particular scenario, whenever you do that, you might have covered most of the actual data and the noise, but not actually, you might have these 5% of data might not exactly replicate for all these various combinations or permutations of the data that you had. So in that case, though your model is highly over accurate, but you might not give you exactly the right picture of or right representation of your model when it comes to the test data. So that kind of a scenario we will call as we have basically overfitted the overfit model, because your test data is very less, and also these you cannot actually verify or validate your model with respect to this data. So am I clear on the previous question some gentleman has asked? What is the difference between overfitting and underfitting with respect to this particular example? Or any follow-up questions with respect to this? Am I clear? Am I audible? Any quick check?
Yes, sir.
Am I very fast or very slow? Feel free to give your feedback.
It's fine, sir. It's
No,
fine.
it's fine. Your speed is good.
Okay. Okay. All right. So the underfitting and overfitting, you are all you all got it. I believe. Let me go to the use case. Right. Okay, so this is very simple. Generally, there are various Python libraries. We call this a NumPy, where all the numerical or arithmetic related formulas or functions are being here. sklearn is the Python library where you will get the various models, okay, whether it is the linear model or linear regression or SVM or various whatever models you call, you will get it in the sklearn library. Okay, but in this case example, as I'm using linear regression, I have called that linear model here. Okay, linear regression. This is the model, and I'm calling it a linear regression. I can also call linear classifier also. Then you have pandas. Generally, it is also kind of a arithmetic. Sorry, it is primarily used for the data frames. So what is data frame? Data frame, basically, it is nothing but a in-memory, you can call as a placeholder to contain the tabular data, right? The tabular data is the rows and columns. You call that as a data frame in Python or Spark or any other programming language, primarily on the Python or Spark or Java. We call that as a data frame. So pandas contains all the data frame related any functions you use that. So we have two libraries called matplotlib or a pyplot. We use that for all graph plotting all the plot related graphs. We can directly call these and use those variable or those parameters to draw the graphs. Okay, matplotlib. Then similarly, Seaborn also is one of the plotting library you can use for this plotting. And you have model selection, basically for the train test split, right? What I call is you use the sklearn model selection package, and in that you can call this function for your operations. Okay, so what basically I am doing it for any, before you do anything, you have to upload the file. One drawback in Collab is whenever you upload, you should it will be there as long as your session is active. If your session is discontinued, you will again have to upload it. Okay, that is, and this is all for learning or practice point of view. You should use Google Colab. Now, what I have done, as I said, like I have imported the AutoMG CSV file. Then I'm trying to display, right? Just see data. So here I am calling this as a see data. Any name you can give. Okay, it is not like you have to give only this name. Any name you can give it. You have to read that. You use that method called read underscore CSV for, because this file is a CSV file. If you have Excel file, you can use similarly Excel function or text, whatever you can call that. But generally in Python, most in our machine learning model, most of the data that we get it, generally it has the CSV format. That's why this primarily being used. Then when you do cdat.shape, let me just run this one, right? Let me delete this, which I've added. I have run this one before, but you have to just click on here if you want to do cell by cell. Then I am running it. Now you see cdat.shape, what it is given. It has 398 rows and 9 columns. Okay. Then you do the data.head. What it will tell is, it will tell you the top 5 rows of that particular file. Now you have to do few operations, right? For example, when you build a model, okay, when you see this one, okay, do you think that car name will have any impact? The name of the car will have any impact on the miles per gallon? Obviously no, right? So you should pick only those where you think that has or might have an impact on your output. That's why what I have done is, and I have tried to drop that column car name, okay, to drop that column in my data frame, and as I have a what you call okay, so as I have a let me call, I think I have to spend some more time here. So when you say categorical variable or a continuous variable, so you should tell whether these variables, what does 1 represent, what does 2 represent, what does 3 represent. These are all the categorical variables, 1, 2, or 3, and all in this particular example, right? These are the discrete values. Now what I have done is, this origin particular column has I have replaced 1 with America, 2 with Europe, and 3 with Asia. Okay, so those things I have done just for my information point of view. Okay, it has nothing to do with the model, but as part of our analysis or exploratory data analysis, what we call in the machine learning terminology, we generally need to do all these kind of examples or exercises. Similarly, what you call, so now what I have done is I am creating some dummy variables. Okay, I would not spend more time on this one because this this is more self-explanatory. What I have done is, whenever I have found one as a whenever I found America as a one of the value in my origin column, instead of making only row wise, what I have done is I have converted that into columns. For example, the first one, the 100, that means it is originated in the America, right? Similarly, some of the records or some of the cars might be originated in the Asia or Europe. So accordingly, either of these particular value will be having 0 or 1. This is something, it's more, the more you practice, it will be helpful for you, but this is nothing rocket science here, right? Now, and then I am trying to find, I'm in my data set that what I have, if there are any missing values, what I should do to improve those missing values, or whether I should replace those missing values with a mean or median or mode, whatever. So those kind of operations generally we do to improve our data quality of the data that we have as an input, right? So I won't spend much time here. These are all, I think I can share this example as well, but I would come to, okay, one thing here, right? Whenever you have a missing value, for example, question mark or NaN values, you can do, right? We'll replace the question mark with the NaN so that you know what you should, whether the data has a right value or not, right? So you can also try to find a pattern of the data, right? For example, the median values. What are the median values of the data? Whether the data is linearly related or not related. All those things you can get information from your these functions. What I have just now displayed. Now, this is very interesting, right? We call this a bivariate plots. So whenever you build any model, right, you should see how these features that you have, whether these features are interdependent or these features have a more impact on the output. So that particular relation between the input and output or across the inputs, right? You should try to know first. So how you will know that? You can know because graphics or visual is always more informative than any other tools or technologies that you have. So what I have done is I have tried to plot a simple pair plot. Okay, there are various number of other plots also. I have done a simple pair plot where I have used my data set CDAT attribute, and this is one of the parameter that we call, and I have drawn this graph. So what this graph is telling, I have the x-axis, I have the various features including your target, and y-axis I have the same values, right? Now in this example, right, for example, what is the relation between model year and miles per gallon? So whether it has got any impact or not. So there is a science, or there is a method to identify whether the model year has any two variables has any impact on your relation, right? So what is the way of calculating that is, okay, I will just show you. So I will just draw two graphs, okay, two lines, this and this, okay. Now if my features here you see it right here. Now here if you draw like this one line and one line like this, if my do you know where to do it here? Okay, so I'm just calculating some points here. Okay, I'm just trying to draw here and some points here. So any x and y values, okay, this is nothing but it represents one x value and one y value, right? Similarly, if any points or data points that fall to either this quadrant or this quadrant, then these are having a positive relationship, because an increase in x value of x will result in an increase in value of y. But if the points fall under your this quadrant and this quadrant, then you will call that as a negative relation, because if increase in value of, if it increases in this direction, y decreases, or vice versa, right? So similarly, the reason of drawing this graph is, in any one of these plots, if you draw one x and y, if you see where exactly the accumulation of the points are more, for example, if you see here, this definitely will tell you it has a negative relation, because as per this it comes like this. Okay, the points are coming like this in this example, see it. But if you see this particular graph, the points are coming like this. So this has got a positive relationship. That means displacement and the weight are positively related, whereas if you say miles per gallon and weight are negatively related, isn't it? If your weight is more, you will have less miles per gallon. A vehicle with it is more self-explanatory, right? If your weight increases, your miles per gallon is here is a measurement of oil, right? So it will go in less gallons. So similarly, you can deduct the various inferences from these graphs that you do. Okay, now the next one is you split the data with x and y what is y, your miles per gallon is your y variable, and x is everything other than your miles per gallon. And then you define a regression model, that is a linear regression model. And once you define it, then you fit that model. So you're fitting the model will be first on the train data, right? X train and Y train. And what is X train and Y train? Here, as I said, right, you are splitting the data into two sets. One is the train data, X and Y, and then test data, X and Y. In this way, you can define, you can take it up. So you are building your model first on the train data here, and you are fitting it. And that model which you have built it, you are trying to implement that in test model. So when you build a model, the performance measure was 0.81, and that model, when you have tested on the test data set, the performance measure was 84. So you have both are very close. So you can go ahead with this particular model which you have built it. Now this is a small example. Similarly, you can try to do with polynomial features, which we call as a degree 2, but that will not be the linear regression model. Okay, when the degree is 1, that is ax plus b, that is called as a linear regression model. But when the degree is more than 1, then it will definitely will not be linear. That will be taken up as a exponential or circular or whatever in that way. Okay, so this is an example on the model that we have built. I will just give a 1 minute pause for any questions before I proceed.
Excuse me, sir.
Am
I audible?
Yeah, you are audible, please.
Sir, first thing is that you have given seaborne and pie plot. So both are used for plotting. Could you differentiate actually what is the exact difference? Because whatever plotting has been given with pie plot, that can be done. With seaborne, shall we get any extra benefit?
Okay. So no, so you will not get any additional benefit, but generally in commercial organizations, right? So they prefer seaborne more because it is visually more appealing. Okay, you have both. Okay, you can see it here, Matplotlib. If you go to site, okay, you have the various functions or various plot types. You can just click it here. So you have various plots. There are various features, or the visually appealing, it is not that great. Okay, but if you go to seaborne, okay, if you go to seaborne side, it is more commercial. Okay, so if you see these graphs, somewhat it is more attractive, isn't it? But why will you give, in order to answer your question, you can use either of this. There is no additional benefit between seaborne or Matplotlib. But if you, some of the features might be, it is easier for a beginners to learn Matplotlib plots than seaborne, because seaborne is kind of a you can build, you can integrate or plot these charts in seaborne itself. At the same time, you have an additional set of features, or the, for example, when I call features, right, it is about how you look and feel, how is the color combination, or how it can be more um, various types of graphs that you can plot. Seaborn has more, but it is also more commercial. When I say it is not an open source for the various features it has, but whereas Matplotlib, it is more open source. Whatever it is there, you can directly plot it, and it is very simple graphs, just like your Excel sheets, whatever you have plots, right? Pie chart or hexagon and all kind of a simple charts. You can get it in Matplotlib. It is the way you try to use. I would say in this example, we try to use both. But
Okay,
generally,
sir, one more query. So like here you have converted that 1, 2, 3 to different country names, then subsequently you made them 001, 100.
yeah.
And so means what is the benefit of this?
Okay.
Is it required
No.
during a regression?
No, see,
Or like prediction?
no. See, it's all, I have built it just to explain what all the various things that we can do in Python. Okay. It is
Actually, this thing we used in classification perhaps, like this, is it like one-hot encoding?
no, you can see whether it is a whether it is a regression or classification. Any of these cases, you have to do these exploratory data analysis. Okay, so it is whether you have to ensure that whether the data that you are using is accurate or how best you can build the model. But what you said is one hot encoding. You can do that in regression also. What you need to do, you have to just convert your input data set into more structured format so that you can use those values while building your model. So, but there are other various ways of you converting it. Here I have done dummy variable. Some cases, if I show you, I think I have that example. I can also do the one hot encoding, whatever you have just now said, right? You can do that as well. I will show you. I have to find that example, but I have that as well to tell whether you should do conversion of this particular feature into 1 or 0 type. And it is not like you should do only in classification. No, it is you should do both in classification or regression. See, till this phase, okay, till here, till your plot analysis, till you convert data into train and test plate, before this, everything you can do both in classification or regression. Your main focus of using whether it is a classification or regression comes only from the splitting and the model point of view. Before that, everything is same. I mean, generally, I follow that.
Sir, can we get this material, because it will be a good one for the starter like us, so we can learn the functions also later on.
Yeah, sure. I can share this. That is no problem.
Share that
But
pull-up file actually. That will be better. Pull-up link if possible.
Yes.
yeah. So what you do is, if I share this file, right? This file, you can upload to Collab and you can do it.
Sir, one more question. Sir, you are here. You are splitting the data using the trend test split. Okay. So, in case of if I use the cross validation, so in that case, is it give the better results than the trend test split?
Sorry, your voice is little feeble. Can you speak little louder?
Sir, here my question is about that whether the cross validation, k-fold cross validation data is more accurate than the trend test split data?
You see, you can cross validation data is more accurate than train test split. That is also, see, there is no ifs and buts. Okay, you have to try the various methods. In you can some cases where you do splitting x file like this, you might get a better result. Some cases when you do cross validation, you might get a better result. Most of the cases when you do a cross validation, the thumb rule is you will definitely get a better result, better optimized here. But in this case, as it is a beginning session, right, I don't want to go in a very big bang approach. I want to go in a systematic way. That's where I have shown you this example. But if you have already done this comfort, you can definitely go with cross validation. No harm in that.
Okay, thank you, sir. Thank you, sir.
Yeah. Okay. Okay, all right. Can I go to, if no questions, I will go to my next example, that is logistic regression. Can I go there?
Yes, sir.
Okay, all right. So as I mentioned, right, in my example, so there are both in regression and classification, you have two types of models, whether it's a linear or logistic, right? So logistic is primarily, it is a classification problem. What is classification? The output is whether yes or no, or one different labels, right? But why we call this as a regression? Because the function y generally, okay, I think I have to put it, okay, we generally represent the equation y is equal to 1 by 1 plus e to the power of minus w0 plus w1x. So this is nothing but your regression problem, right? Regression equation. So that's why we call this as a logistic regression. But actually, logistic regression, though it is by name it is a regression, but it is a classification problem. Okay. So now I will tell you a brief, a quick example that I have. So what we have in logistic regression is whether a patient, let me open the data set first, right? Let me close this. Yes. So, so whether a patient who has, see, this is one thing I would like to say, okay, as I mentioned at the beginning of this call, right? You can use the machine learning models in various applications, right? Whether it may be a banking or telecom or retail or healthcare or supply chain, whatever you can use it, right? So, but the concepts are important here. So the persons who are working in that particular application, they would be knowing what is the significance of each of these values, right? As a developer, as a programmer, we only know how to build the models, but what each value signify, that subject matter knowledge they would be having it. That's where when you build a model with your domain, right, you would be more close to the data. You will understand the data that would help you to build a right model. Okay. For example, here, this is a set of data that we have where there are it's a healthcare data, right? There are like you have how many months since one person is pregnant, right? Or what is the plasma levels for that person? What is the blood pressure? Whether the person has any skin related allergies or diseases? What is the blood levels, right? The testing levels, blood sugar levels, and all. What is that for that person? How that person is? What is the BMI, body mass index, right? What for that person? What is that? um, uh, and similarly, I don't know what is this, but there is also one of the feature that it has, and what is the age of that person, and based on these parameters, whether the patient is diabetic or not. If 1 is diabetic, 0 is not diabetic. So this is definitely a classification problem, isn't it? Because your class output is 1 or 0, right? Now, what I am going to do is, based on this data set, I am building a model. Okay, building a model. In fact, logistic regression model, and then I can derive the whether it is a person is a diabetic or not. But the main focus area, right? All these data analysis, data preparation, you all need to do at the beginning. And I would rather say, though it is more as a programmer, as a machine learning model developer, you should spend considerable amount of time in understanding the data, though the steps are almost similar, and then you should focus more on the performance measures, what I call, right? I have explained what is the various performance measures. Now, for example, here, right, I am going from start. I have done this, import libraries, then I have the data that I need to upload. I have not done it here because I have run it before I am in this class. So then I have taken the various headers of the data just to see whether any discrepancy or values in that, how many null values are there, right? Any null values are there in this data, it's showing as a false. That means there are no null values in the data. The data seems to be looking good. Then I have built the plot. You can build various plots here. I have built a histogram in this case just to show what is the pattern of the data and all. Then how each what is the correlation between the various parameters, right? I have just displayed in the previous example. Did I do any correlation? No, because I have done the plot. In this example, I have built a heat map. I won't call it as a heat map, but this is a correlation matrix where on the, if you can see, when you do a correlation matrix, the diagonally everything will be 1. Because when you say pregnant and what is the independence or what is the relation for this column with respect to x, when both are x and x are same, it will be matching, right? But wherever you see how highly correlated are which two values, if you can see it here, definitely minus 0.08 skin has a negative impact on, sorry, the pregnancy has a negative impact on the skin. So similarly, you have various what you call the relationship index. We call it as a relationship index. However, wherever it is more, for example, here 0.54, that means age and pregnancy has highly correlated with respect to the class. So same diagram, same example, I have tried to build in a heat map, right? Just to tell you whether it makes sense. But here, if you can see, this is very highly deep. These all parameters, you can try to drop these columns so that you do so that your model, final model, will not have any impact, because if two in this, if plasma and pressure both have a same impact on your output, have a similar impact, right? Then even if you drop this column, the output will not have any impact. So that's why, in order to reduce the compute resources, right? When in general, when you do any model, the data will be too much, right? It's only 760 records here, but generally it will have millions and billions of records. You will get it, right? When you process your program with so much of high volume of records, definitely your CPU should be more, right? Your computing power. So that's why you should reduce the from a technical point of view, you can reduce those so that your CPU utilization and all is very less compared to keeping unnecessary features in your data set, right? So similarly, you are trying to, here I am trying to find what is the dioptric ratio between true and false from outcome variable. It is very same number of true cases, false cases. What is this true and false? I told you here, right, in this example. This is very important, right? If I go here, so your true positive and true negative, false positive, false negative, these two are errors. Now this should be as less as possible. So that is what I am trying to know from this piece of code what I have written. I try to find how many true and how many false cases. Now then I'm trying to split the data between train and test, and then I'm trying to check what is my true and false values. Still I don't see any significant change. You can see it here. Still it is almost similar. So what I am trying to find is why I'm not getting the right performance what I am expecting. So that because of the various hidden missing values, or there are so many zero values are there. I'm trying to, what I have done is, generally what we do, we replace zeros with a serial mean or median depending on analysis of the data that you have. Then finally what I'm trying to do is I'm trying to use the logistic regression models, right? I want to spend 2 minutes here, right? When you build any model, okay, in machine learning, you have two types of parameters, okay? One is learning parameters, okay? One is hyperparameters, hypertuning parameters, okay? Now, if you see here, right, in this example, now whenever you do logistic regression, there are various types of solvers, okay? If you click on here, generally whenever you do a solver, you can go to logistic regression package and you see how many types of solvers are there. I have used a liblinear. Like that, you have other types of hypertuning parameters are there, like liblinear or EDA or similar few others, right? Now you can try using the various parameters that are available, and then you should fit the model, okay, for the trained data set, and then you predict it for the test data set. Here, what is your coefficient, right? That A and B values, right? In the exponential parameter, right? Whatever the coefficients. So your Python will drive you the model that you need to do. But for that model, what is the intercept and the coefficients? Those, if you wanted to know, you can define that, and it will show you here. Okay. And then what you do generally do is you calculate the model score by using this particular function. Here the score is 77.9%. Then what is your confusion matrix? How do you call the confusion matrix? You have to just call the matrix package, the function confusion matrix. You have to pass these values, and then this is predicted 1 and 0. This is actual 1 and 0, right? So here is true positive, false positive, true negative, false negative. So based on these parameters, you can identify what is the type 1 error, type 2 error. Here it is 14 and 37. So one thing, it is very confusing for you, because the way people, some of the examples that are there online, what they do is they reverse the this particular graph, this particular table, right? Sometimes someone keeps prediction here and actual here. Some people keep actual here and prediction here. So accordingly, you have to know what will be your true positive or false positive values. Okay, so I will share this these two examples also. Okay, but you can go through it and try to understand, and definitely we can discuss. But any fundamental or queries that you have, please feel free to ask before I move to the next example. It is very interesting. Okay, I would say coming days, everyone is turning towards the machine learning models. Okay, you should. I mean, it is. It took me 17 years, almost 16 years, because to get an opportunity to learn and work in machine learning. You are just the millennials, right? So you are on the you are on the platform at the right age, right time. So there is no difference between someone who is, because the market is opening up, the applications are, everyone is trying to use machine learning models. So I would say you should spend more time on learning all these, implementing all these concepts, and practice more, right? The more you practice, the more you will learn it. Some of them, though you find it is very easy and all, but the real crux of any machine learning model, I keep on saying, lies in the first, how to identify the data set, and you have to understand what the data set is about, what are the various relationship between the data set. Accordingly, your model will go on. Trust me, to build these models, I have built this model only after 2 months of learning on the Python packages, the Python tools and all. But I don't want you people to spend those 2 months, right? If you can share these examples, you should try to quickly understand the code, whatever is written, because I have clearly mentioned about the various details, description and all. So it is very, it would be helpful for you all also.
Excuse me, sir.
Mm-hmm.
So that heat map actually gives, means what is the meaning of that heat map? What kind of conclusion we can draw out of this heat map?
Okay. So the conclusion will be like, see, this heat map is nothing but a visual representation of this particular correlation matrix. Okay. So here what you are seeing it, for example, the variable pregnancy, how it is related to plasma with respect to the your output variable, right? Or your output is a class. Now, wherever you see the heat map, if this relation or this particular index is close to 70 or 80% of between two variables, what you can do is you can drop any one of the variable. You don't need both. In this particular example, you don't see any value which is close to 70 or 80%, right? The highest relation that it has is between pregnancy and the age. You have 54.54 relation, right? So if you have, in some examples where I have seen, where this particular value will be near to 80 or 90%. So in that case, what you can do is you can keep either pregnancy column or age column, because both are highly correlated and have a similar impact on your output. So it is just a duplication of the particular value, you can say, with respect to the output. So that's where you can, to answer your question, based on the heat map, wherever you have seen the higher correlation, which is more dark, right? So those things you can see, am I getting a different model when I drop this column, like skin, because skin and pregnancy has got more correlation compared to the other values, right? With that is the one of the thing that you can infer and take an action for your model. Did I answer your question?
Okay. So wherever there is high correlation, we can drop that. Means it's the
Yes.
kind of data cleaning or data pre-processing, a part of data pre-processing.
Yeah.
Okay.
Excuse me, sir.
Mm-hmm.
This actually needs lot of hands-on. Being the beginner, in my case, it needs.
So see, I understand and I agree with it. Okay,
Sir.
but what you need to do is, okay, that's where I see you should go this step-by-step process.
Right, sir.
The best way to do is, see, all you cannot be expert from the day one. Okay, all these models are having same steps till here. So what you need to do is you build, if you are building these, for example, if I show you one example, I think what I have done even for Trupti only, see, I want to show you this example. Okay, this is an example where we wanted to find the bending, how much bending can happen, right? So if you see, I have forget about all this. This is because AN and all. But here, yeah, see from here, not here. Yes. So from here, I'm using the X and Y, but I'm building with the same data set, I'm building 3 different models, right? Decision tree, random forest, and LGMR with the same data set. Okay, so yes to your question, yes to it. It needs some hands-on, but if you try these models, at least if you try some effort on 5 to 10 models or 5 to 10 programs, you will be more confident. See, so that is something anyone has to do. So there is
Right.
no,
Absolutely right.
Yeah,
if
there
we
is no.
go for developing 4 or 5 models, then only we can have very.
Yeah. So we have these more examples. You can refer these. You can go through.
Right.
Fundamentals remain same. So whatever you have, I have told you. If you keep only those things in mind, right? And
Right,
if you
sir.
try, it will. See these. Whatever I told you in the last 1.5 to 2 hours, it is something I learned over a period of 2 years. Okay. So, but I don't want you to spend 2 years to learn to this stage. But the best thing what you should do is try 5 or 10 models for various examples. It may be nearby classification, KNN, or decision tree, bagging, boosting. Multiples are there. Okay, you have to just try it out. Any questions before I have to cover, I think, another 10 minutes, 10-15 minutes I will take. But any questions still here?
No, let us move forward.
Okay.
Let us try to complete the time.
Okay, all right. So now coming to, there is something called ensemble techniques. Okay. So guys, why we do all these models? All these models we do because we wanted to build some automated mathematical models, right? So, but when you build, if you build one particular model, maybe it may be linear regression or decision tree or random forest or SVM, whatever it is, right? If you build only one model, you might not get. See, let us think like this, right? Here we have a team of, we in this particular call, we have around 90 set of people, right? Now, everyone has their own model of thinking, isn't it? Trupti
Yes,
thinks
sir.
differently, I think differently, you all have things differently. So everyone thinks differently, but everyone's objective or achieving certain things is same. So similarly, if you say every model based on the trained data, whatever input has been given, every model gives you an output, and some of the output may be more accurate for some set of data, some of the output may be more accurate for another set of data. So your data, your output for which you are building the data behaves differently for different set of data, right? So what you need to do, there is a technique called ensemble technique in machine learning, where you build multiple models. Okay, you don't build only a single model. Okay, you build multiple models and you combine them for a single output model. How do you combine them? You can combine them. Primarily, there are various other ways of combining, but in a uh, for the lack of better word, what I'm in the most applicable ways of combining in the current industry is, there are 3 ways. One is you can combine using a voting. You can combine using averaging of the outputs for or performance or accuracy of all the models, or you do combine with giving specific weightage to certain models, right? That is one way. So what is called voting? For example, you say, for example, if this particular model has more number of success ratio, then you generally what you do is you give preference to the maximum. As this particular model has a maximum success ratio, you are voting this particular model as a defined model. But there are others also who can contribute in the consolidation of all the models. Similarly, averaging or weight. There are two other techniques. But the more important way is whether you should when you combine, whether you should combine using the various parallel models, or for example you run this model, all models you run at the same time, and then you do you combine them, or you combine running the model one after another. You can have a series way of combining, right? So you in electrical you have a star or delta or whatever connection. So similarly you also have it here, a parallel or a series way of combining. Whenever we have a parallel way of combination, we use the method bagging method. Okay, we use the method bagging here, and when we do a series combination, we use the method boosting. Okay, again, boosting has two different types of boosting. We call adaptive boosting or gradient boosting. I will show you the in my use case example. But in principle, we do all this because we want to get a model which is not biased to a certain set of data. It is a more unbiased model, and it caters to the different sets of data that we have, and that way we can combine the models. Now, the other way of putting this is primarily on the random forest types of models what we build. In that, what we do here is, let me show you example, right? So when we split between when we build the models for train and test data, either you can do a vertical splitting. For example, you can build few models taking only these three features into consideration, but all the data set that we use in the train. And for another model, model 2, you can use only these two, and model 3, suppose you can use these two. This way, if you build your model, that generally is used in the random forest models. But if you partition your data set with respect to horizontally, if you take for example, this set of data for one model, another set of data for another model, similarly if you partition it, that you generally do it in decision tree or your bagging method of combining the models. Okay, so this is something you should keep in your mind. Okay, now I will go to one example, simple example where I have done this particular use case. Where you are, what is your data set? Yeah.
Please make this font size again. It is very small looking. Very
no,
small.
I will increase that because I opened so many slides, right? Let me do that.
It is very small. It's in fact the font is absolutely not very. Yes, now it is. Okay.
Okay. Okay. All right. So so here, okay, this is particular one example. Okay, this is in a banking sector. where we are going to build a model to know whether we should someone who is seeking a loan, okay, whether that person will be a defaulter or non-defaulter. So for that, what are all the various ensemble techniques that we should use? That is something I have tried to achieve or accomplish in this particular example. I will show you the example. Let me close this. Okay. Is it visible now? This one is visible, or you have, I have to increase the size?
Visible, sir.
Okay.
It's fine.
Okay. So in this particular data set, we have almost 17 features, sorry, 16 features and one target value, where I'm trying to get whether the checking balance, what is the value, what is the loan duration, what is the credit history of that particular loan seeker, for what purpose they are trying to get it, how much amount, what is the savings balance, how much that person is employed, what is the percentage of income. So all these features, right? So all these features are there, and based on this is a real data set, okay, based on this we try to the actual value, whether for these persons whether he is been a defaulter or not, right? So that is my classification problem, right? Now how I will build, right? Simple. I can do with the same data set, I can build a logistic regression model. Definitely I can build it. With the same data set, I can build the various other models also, right? So that is what I try to achieve here. All these EDA, exploratory data analysis that we do, I try to get the various value counts, how many distinct values are there. Then I have built, see, this particular one hot encoding or label encoding or whatever, you see, this is what I showed you, right? All these things we can do using one hot encoding. This is something you can do using direct Python functions. You can also write a your own function to define that one hot encoding as well, right? So then I have tried to implement that, and then I have splitted the data for x and y variable, default and not default column, which is a y data. Then I have taken a example of test size is a 30, and then I have built a simple decision tree model. Okay, there you can see it here. Okay, trust me, decision tree is something I'm explaining in this here. But what you generally do here is, I think I have here, yeah. Generally, what I have done is I have tried to take one feature like checking balance. I have tried to see whether how many are less than equal to 0.0. So that is my first node in the decision tree. Similarly, if it is a true, then false. If it is true, then I have taken another tree node for other credits, none, whether it is in dot less than equal to dot 5 or not. This is basically what I have done is I have tried to build a tree-like structure using my decision tree model by using the various features that are there in my provided data set. Okay, so based on that, I have built my data, built my model here. So I won't spend much time here. Then I try to do again the what is a confusion matrix. Then I try to see here is you have more the what you say, no and yes, right? So this is true 143 and 40, but your problem is 31 and 46, right? So this is something you need to reduce it. So how I can, this is my typical regression model. I have not done any ensemble techniques here, but in below what I have done is same. You don't need to do anything. You have to just call this bagging classifier, where you need to define certain hyperparameters, right? I have taken my base model as a decision tree. Okay, then I have given my estimators as the 50 and random state 1. So what is estimator, what is random state? I am going to have 50 nodes here, and random state is something which I think I should tell you. So whenever you split between train and test data, right? So how the system will know when you run the same model, or when you split the same data set next time, it should give you the same number of records between train and test, right? Then only you will have the similar accuracy or a precision or the root mean square error, right? So for that, what we do is we lock that state to one particular value. So if you lock to one particular value, then your various split or various models that what we do, that that remains the same for various data sets whenever you are going to split it. Now then what I have done is I have imported my models. Then I am fitting that model for the train data set using bagging. So what I told you here, right, whether it will be serial or parallel or different types of boosting, all these are predefined and preset. You have to, I have tried to explain you how these work behind the scene, but when it comes to implementation, right, these things you have to just call certain packages or methods. Behind the scene it will work the way I have explained, but you don't need to go that level of details. But for understanding point of view how it works, you should see it here, right? For example, here when I do a bagging, and then I have tried to do ensemble learning using ADA Boost, which is a series type of a machine learning model. Then similarly, you have a gradient boost. So someone might ask, what is the difference between ADA Boost and gradient boost, right? So that is also I try to keep it here. Where is this? Yeah, this one. Let me put it here. Okay, I will try to explain here. Now, what we generally do is any decision tree model. Okay, this particular example. Okay, I'm just trying to keep the concepts clear. Okay, in this particular example, what I have it here is I'm trying to segregate this data set. Okay, there are 4 plus symbols are there, and there are 4 minus. So there are 2 different data sets here, just to for explanation point of view. When I build a decision tree with x1 value, x1 as a value between less than equal to this particular condition, then I will get a model where these 1, 2, and these 4, mainly these 2, will not be on the right side of it, isn't it? These two, I should build a model to segregate between this data set so that negatives and positives should be on the both side of the line. But in this case, when I build, right, to cover the maximum segregation. In that case, these two values are falling to the wrong side of my model. So for that, what I need to do, I am trying to build another model where I am trying to give my x1 value at this threshold, right? In this case, I am getting the right set of data on the right side of it, but still there are these two values are falling on the wrong side. For that, I have to build another model to give a value as on a horizontal line, so that these two also will be covered. So this particular way of doing it, right, though you don't need to explicitly know how ADA boost or gradient boost works, but whatever I explained, this method basically it is nothing but the ADA boost. Here it tells you, it defines you a label here, and then for each of the data frame or each of the values that are there, I'm trying to segregate between what is the maximum. So it is an iterative basis. When you run this program, right, it runs behind the scene in an iterative way, and then it gives you a combined model. Unlike in a gradient boost, where it is more on the random forest type of things, where you will get more selective columns, right? In this example, you will get it more subset of the vertical partitioning data, which happens in the gradient boost way of ensemble technique. Similarly, I have done the random forest here, where this is another way of ensemble technique, but I'm taking it partially. So by this model, all these three models, if you can see it here, right, though as I have a limited set of data, that's why if you see the score for these three, I'm getting as 0.74. Here also I'm getting as a 0.74, but in random forest I'm getting it as 77% of score, which that's why this should be the true selected or optimal model that we should consider when we do ensemble technique. So that is something I wanted to say. But yeah, so and similar approaches, what you do, you have to calculate the confusion matrix with true positive, true negative, false positive, false negative areas for all these things. And then you should also try to see when you see this particular graph, what you're doing is it should be uniform. But if you see, if the right side of the tree is more weighted than the left side, that means your model is not the balanced model. It is more unbalanced model. So you have to try to, that is where we have gone to build the ensemble technique models, where you can see it here, it is more balanced. Here you can see it here, it is more balanced. It is only unbalanced only on the last node, but till that time it is more balanced on both sides of it. Yeah, so with that, I think I tried to cover whatever I planned to cover in this session. I covered decision tree, naive Bayes. Okay, naive Bayes is something I have not done, but I will share the example here. Okay, any questions till now?
Excuse me, sir. So
Yeah.
ensemble technique, what I know is a combination of multiple classifiers.
Yeah.
But then why you are mentioning it that ensemble decision tree, ensemble random forest, why you are saying like that? I could not understand.
Wait, okay, here. No, see, so you can build, okay, let me come to here. if you build only one model, okay, if you are building only one model, then that is not ensemble, right? You are not building multiple models. You are building here decision tree, only one model here. But when you call these, where is that? Yeah, when you call this particular bagging classifier, that will use various models, right? It might use decision tree, it might use random forest, or it might use SVM, whatever it might use, right? Inside.
Is it like randomly it will select? Like you are saying that it may use random forest, it may use SVM.
No, you are defining it here. No, you are defining it here, right?
Okay.
You are defining it here.
Achha.
So, but AdaBoost, it picks up from
But
your own
then,
model.
sir, it is like a single one. It is like a single one we are defining. It is a
No,
single
no.
classifier
See,
we are defining.
no. Here, see, first of all, AdaBoost and Gradient Boost, by default, they are ensemble methods. Okay, you don't need to define explicitly for these two methods. These are all series methods. But here you are defining that there are 50 estimators, right? So there will be 50 types of models that it will be internally calculating or internally processing, and then it will give you the final model. You don't have to. I have explained this one to know how it operates inside the package. Okay, but you don't need to explicitly know. If you give here estimators lesser number of it will only those many models it will build. But how it will be combining in Gradient Boost or in AdaBoost, it will combine in a series way. Whereas if in your not this one, whereas in your bagging method, it will do it in a parallel way, all the estimators whatever you have. So you don't need to, here if you see here, it will do in a, this is a bagging classifier. Okay, so here it will do in a parallel processing method for all the estimators that what you are defining it. But in AdaBoost and Gradient Boost, it will combine all the models in a series way. So to help, so you don't need to explicitly do model by model in it. It itself, all the statisticians and all the mathematical giants who have built these models, okay, who have built these packages, they have already taken up inside the program what they have written. So you have to just use them as per your needs. Did I?
Yes, sir. Yes, sir. Yes, sir. But when they are parallelly combined, finally, how the result will be obtained through voting?
No. See, I told you for your information, for your knowledge point of view. Okay. There are three ways of generally if you want to build an ensemble model on your own. Okay, not on these what you can do, you can also write a 4 or 5 models. You can store the output of one model and build another model taking that as an output, as an input, and build your model. You can do that manually one after another. But in industry, what are the 3 different ways of combining? some do voting as a method for maximization, some do averaging as a method. So in this example, right, I have not called all the parameters. There are, if you go to ADA boost classifier, there are n number of hyperparameters that are there. In that also, you can define what should be your criteria. You can define as a voting, you can define as a average, or you can define as a weighted average. All those things also you can define in each of these models. So, but here I have given only 2 parameters, right? Like that, you can give n number of parameters. If you go to
Okay, then how actually in this example, how you have combined then finally out of these 3 methods, how you have combined?
See, in this example, I have combined what is the, I have not done anything here. What I have done is I have just used the classifier to combine the 10 models. How I have combined, I don't have to tell that explicitly here. This particular, the AdaBoost classifier, whatever it has been there, that internally checks into all the models. Whatever is the best model as per, sometimes it may use voting, sometimes it may use average, sometimes it may use weighted, but it does for all the 3. Whatever is your best output, whatever is the best score, that it chooses and it gives you the output.
Yes, sir. Yes, sir. Thank you.
Okay. All right. Any other question? Okay. Trupti, I think
Yes, actually they are asking for the collab link.
Collab link, right? What I can do is I can share these files to you, Trupti. I can, they can go through it.
Okay, okay. Okay, participants, thank you for bearing with us. We are already, I think, 30 minutes, 40 minutes late today, but the
I am
session was
already getting,
so interesting.
3 calls already. So, but yeah.
Actually, the session was so interesting, and I personally feel it to be very much informative as well as useful. Uh, so I also believe the participants, you must have had a very nice session today, very useful.
Yes, sir. Yes, sir. We had a very good session today.
And as what Bikram will be available with us on Thursday first session. So prior to that, I will ask him to share the collab link and all the files so that you can have practice with you, and you can go ahead with your doubts on that day as well. So we'll again meet on Thursday, Vikram. So I will not bid a formal thank you today. So that day we'll have our a formal photo session with participants having their camera on. So so with this, I thank Bikram for today, and I look forward to have a similar session on Thursday, 25th at 9:30 a.m. Okay, so participants, you can sign out now. Thank you again.
Thank
And
you. Thank
as
you
soon as
all.
I
Thank you,
receive the
Trupti.
materials from Bikram, I will be sharing with you.
Yeah,
Thank
sure.
you. Thank you.
Yeah, thank you. Thank you all.
Thank you so much. Thank you to everyone.
So tomorrow, all of you kindly join in time. We'll start the session at 9:30. So please join 10 to 15 minutes prior to that. Okay. So thank you. And
Sure, sir. Thank you.
thank you.